Okay, today it is 3/7/19. So our objective, we're going to be simplifying radicals. Or another way to say that, or roots. When I say roots, we're talking, square roots, cube roots, all the others, right? So, okay. So let's take a look at number one. So again, what we're trying to do is this, we're trying to find perfect square roots. Now those numbers are like 4, because what's the square root of 4? 9, square root of 9 is?
3.
16,
4.
25, 5. Okay, and so forth and so on, right? So we're looking for perfect squares because we can take those. So in example 1, I'm going to rewrite this as the square root of 9 and the square root of 3, right? Because that makes 27. And what we do is we take half. We really do take half the exponent because we know x to the 4th times x to the 4th makes x to the 8th, right? So we're really going to take half the exponent, okay? And there's a reason we do that. We're going to learn later on that the square root of x is like x to the 1/2 power. We're going to learn that later. And it kind of makes sense because there's an invisible 2 here we never write. And there's an invisible 1 right here. So the reason we take half the exponent is because the exponent really is 1/2. So if you take half of 8, you're just left with an x to the 4th. Okay, square root of 9 is 3. X to the 4th, square roots of 3. Gavin, how's that?
Mildly confusing, but I'll get through it.
Okay, all right, you got Ledger to help you out too.
Yeah, he's not much help.
Okay. Yes, Daisy.
So,
Okay, good.
when you take out a number and there's already a number in front, do you multiply the numbers or do you add them? Like, when you take
Multiply.
3 out of the 18, so
Multiply.
that would become 6.
Yep.
Wait,
Well,
no,
9.
9.
Yeah.
9.
And you know why we do that? Right in here, in between, there's an invisible times sign. Does that make sense? If they're right next to each other, it's like 3x or whatever. There's an invisible times sign, okay? So let's do number 2 since you're ahead of me. I like that. So the 3 is a regular whole number 3. Leave it on the outside. But 18 we're going to break up into the square root of 9, square root of 2. Now, if I'm going to take half, okay? If I'm going to take half of 7, I'm going to get a fraction or a decimal. I don't want that. I want to take half of a number that can be taken half of. So I'm going to rewrite this as the square root of x to the 6 and the square root of x to the 1, okay? So I take 1 away to make it even, right? Because I want to take half of it. So I've got a 6, which I can take half of. So I'm going to go this 3 times, right, Daisy? Square root of 9 is 3. I'm going to take half of my exponent, so I'm going to get an x to the 3rd. And then the 2 and the x, the square root of 2 and the square root of x, you can't do anything with it. They're going to just have to stay as the square root of 2 and the square root of x because you can't. This is actually like a 1.41 blah, 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 blah. It's a really ugly number. It's an irrational number, so you leave it alone. So I get an answer of 9x cubed square root of 2x, right? I will. Yeah, if you haven't seen this before, it's brand new. I know for most everybody who's had me before, we've done this, right? Right, Kylie? We've done this. One of the things I like about the new curriculum that we adopted is that you see the same algebra, the same algebra, and the same algebra. And that way, you don't forget it. We just build on it, right? Okay. Gavin, how you doing?
Pretty good.
So let's take a look at example 3. Let's multiply, okay? 15 times 5 is 75. But it's still square roots, right? It's still going to be a square root of 75. I haven't taken a square root. I've only multiplied 2 square roots, right? And then 75, right? How about 25 and 3, right? We know we're looking for a perfect square root. So square root of 25, square root of 3, square root of 25 is plain old 5, square roots of 3. There's my answer. Yeah, Johanna.
Or since you know that 5 times 3 makes 32, you can just do 5 and it's really
I like that way. Yes, that's the way I do it, but I don't teach it that way. Totally right. Okay. All right. Now 4. So multiply whole numbers with whole numbers. We're going to get 8. Multiply square root numbers with square root numbers. Square roots of 18. Okay. And now we can break up the 18. The 18 would be 9 and 2. You guys agree? So we're going to go 8 square root of 9 square root of 2. I know the square root of 9 is 3, so I got 8 times 3 times square root of 2, because square root of 9 is 0.03. Yeah, so we get 24 square root of 2. Good job, Daisy. Yep. Okay, yeah, Gavin, I'll wait for you.
You can't add square roots.
You're right, you can't. You're ahead of me. I like that. You cannot add square roots because say how many of these plus how many of these are different. But maybe if we do a little reducing, maybe if we simplify these, they might be the same. Let's find out. Okay, so I got a 3. What times what makes 8?
4 times 2.
Yeah, square root of 4, square root of 2, plus what times what makes 18?
That would be 9 times
Yep.
2.
Yep, perfect. Okay, now let's keep going. Square root of 4 is 2, so I got a 3 times 2 square root of 2 plus square root of 9, 5 times 3 square root of 2. Okay, Gavin, how am I doing?
And then when you add those,
So the rule is you can't add them unless they're the same, because it's saying how many of these plus how many of these do you have. Well, you can't add them unless they're the same, but I'm going to get there. After reducing my roots, I'm going to get 6 square root of 2
so that
plus
would be
15
4
square root of 2.
roots of 2.
You're awesome. Okay. Yep. And now they are the same. I got 6 root 2 plus 15 more root 2 is going to make a total of 21 square roots of 2. Okay.
And then
I'm going to distribute. Yep. I'm going to distribute. Yeah. Okay. All right. So you ready?
Yeah.
Gavin, I'll wait for you.
Okay.
Let's multiply. This times this. This times this. We're just going to distribute. So I'm going to get. Okay. Remember, multiply real number, or I'm sorry, not real numbers, but whole numbers with whole numbers, square root numbers, square root numbers. Okay, so I'm going to get a 6 square roots of 18 plus 15 square roots of 9. Okay, just multiply whole numbers with whole numbers, square root numbers. Okay, I can't add these, but I can reduce them. So I'm going to go 6, and 18 is going to be the square root of 9 times the square root of 2, right? 15 times 3, because square root of 9 is just plain old 3, right? How am I doing? Okay, 6 times 3 square root of 2 plus 45. 6 times 3 is 18 square root of 2 plus 45. Don't add them. Don't add them. They're not the same. This is a bunch of square roots of 2's. This is not. This is 18 square roots of 2's. This is just 45, right?
If you put a 45 inside, it would be so much better.
Yeah. Okay, 7. We're just going to FOIL, right? We're going to double distribute, whatever you want to call it, right? We're going to go, this times this, this times this, this times this, this times this, right? We're just going to do a big FOIL. So, first, 2 square roots of 3 times 5 square roots of 3. Let's do that first. I'm going to get a 10 square roots of 9, okay? I'm going to go 2 square roots of 3 times a negative 5. Now, when you multiply these, you multiply the whole numbers. I'm going to multiply the 5 times 2 gives me a negative 10 square roots of 3. Okay, you see that? Negative 10 square roots of 3. So you still have to multiply the whole numbers, okay, and then bring along the square root of 3. Same thing with the 1 times 5. 1 times 5 is 5. I get a positive 5 square root of 3. You just have to multiply the square root of 3. Yeah, Gavin?
Where'd the second 10 come from?
Second what?
Second 10. Does the 10 square root of 9 minus 10 square root of 3?
Oh, right here, outside.
Oh, there's 2 5s there.
It's all good. Good question. Always ask, okay? And then finally, what's a 1 times a negative 5 is a negative 5, okay? So I multiplied it through, just did a double distribute, right? So, 10 square root of 9 is 3, right? These two are the same, so we can add them, right? Minus 5 square root of 3 minus 5. I'm still not done, though. Still not done. Okay, because I've got a 30 minus 5 square root of 3 minus 5, right? I'm still not done, right? But I'm almost. So now I'll have a 25 minus 5 square root of 3. Boom. How am I doing, Daisy?
Could I just add the 25 in the back?
Yeah, you could rewrite it if you want the negative 5 squared to 3 first, yeah. Order's not important on these. It's not. Only with the eyes is more important, okay? All right, turn the page. Yes? Cole, you got it? Okay, I'll wait for you. Gavin?
I'm good.
And Cole, you remember doing these back when you guys were in algebra?
Yeah.
Yeah, we did a little bit of this, right? Okay, and turn the page, okay? All right, now, here's how it works. If you have, oh, I thank you. If you have something to a fractional exponent, okay? If you have something to a fractional exponent, the top number is the power, and the bottom number is the root.
Can you scroll to the left?
Yeah, there you go. So the top number, so if you have a fractional exponent, the top number is the power, and the bottom number is the root. So if I take a look at example 8, I'm going to rewrite this as the 5th root of 32 to the second power, okay? So, you ready? So now you have two choices. Great question. Really good question. So I don't really need the parentheses. I don't. You're right. But I've got two choices, and I know which choice I'm going to take. Okay, listen in. I could take and square 32, which could be a really big number, and then I could take the 5th root of it. Or, and that will work, or I'm going to take the 5th root of 32 first, so because I can do that in my brain. What times what times what times what times what makes 32? 2, right? You can do that in your head. You guys agree? 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So I know that the 5th root of 32 is 2, and then I still have to square it.
Would it be 4?
That's it.
That's the whole answer.
That's not so bad, is it?
That sounds much easier.
I agree. So how about example 9?
So that would be
We could rewrite it as 27 to the 2/3, but, okay, you with me? 27 to the 2/3? But let's just do it. Let's do the root first. What's the cube root of 27?
3,
Okay. And then 3 squared is
9.
9. Now, granted, on these, and I will tell you this, I'm going to be honest with you, on these, since there's no x's, you really can do these on a calculator. You really can. So, for example 8. I mean, I don't mind showing you the technology. Caleb loves the technology. So if you go, for instance, 32 to the power of 2/5, right? Check it out. I mean, if it's there's no x's, they're just numbers, right?
How do you do it?
And boom, enter is what'd you get?
4.
What did I get? 4. Okay. Okay. Same thing on this one. I could go 27. Whoops, 27 to the 2/3. Right? 9. Okay. I can do it in my head faster than finding a calculator, honestly. Okay. Now, solve for example 10. Okay, now here's a problem with example 10. We're probably going to get a decimal answer. So let's round to the nearest hundredth. Okay, we'll round to nearest decimal, okay? So I think on your homework they're going to ask you to use a calculator. Well, I can do that. But before I do anything, what's the first step in this problem? What's the first step I should do in this problem? Say it. Divide by 2. Thank you. Everybody agree? Divide by 2. Divide by 2. Right? Cancel out that 2. X cubed equals 30. And now what?
You get the cube root.
Cube root. Now you get two ways to get a cube root. Okay, and I'll show you on a calculator. Cube root of 30 or 30 to the 1/3 power. Both will work. Which one do you like?
30 to the 1/3 power.
Okay, I thought that's what you'd say. Now I will show you where the cube root button is because it's in your math. If you go to your math button, let me get this so you can see it. Go to your math button, and there it is. You guys see the cube root right there down there? Cube root, right? So your calculator will do cube root of 30. Daisy, I agree with you. I think it's easier to go 30 to the 1/3 powers. You guys agree?
Mm-hmm.
Yeah. Boom. Same answer. Okay. Does that make sense, everybody? Yeah, Gavin.
Math, then number 4,
Yeah.
then what?
Enter,
Then enter.
and then type in 30. Here, I'll do it again. Math. Number 4. Now it's asking for a number, right? So, okay, what number do you want me to take the cube root of? 30. Boom. Now you can do an any root. For instance, even if I want to do number 8 real quickly, I'm going to go back to 8. If I go back to math, it does not have a fifth root, does it? Okay, if I take a look, if I go back to number 8, it doesn't have a fifth root. So I have to tell it. Now watch carefully. Now I'm probably going to do this one to the 2/5, but if you need to find the fifth root of something, watch, okay? Quit. I'm going to hit 5, because I need to tell it to do the fifth root. 5, math, any root. Okay, watch. So I'd tell 5, because I want to do the fifth root, okay? So I'm going to do any root. I push that answer, boom, look what happens. Made it a fifth root, didn't it? Fifth root of 32 squared, right?
But it's so much easier to do in one.
I agree with you. I agree. But I wanted to show you that little feature, huh? Totally agree. Okay? Last but not least, okay? Example 11, okay? What are we going to do? Okay, so what's the first step?
So we're going to find the square root.
Square root. And I might just keep it and reduce it because I can do this. So I've got x minus 5 equals what? Square root of 50, right?
Yeah.
How many answers is this problem going to have? 2. So it's going to be plus or minus the square root of 50. You okay with that? 2 answers, everybody agree? 2 answers. Okay, and then what am I going to do? Okay, I'm going to go x minus 5 equals plus or minus the square root of 25 times the square root of 2. Why not? Why not, right?
Yeah.
X minus 5 equals plus or minus 5 square root of 2. And then let's add 5. X will equal 5 plus or minus 5 square root of 2. Because when I add 5, when I go plus 5, you can't add those. You can't add those because that's a square root number and that's not. And there's my 2 answers. 5 plus 5 square root of 2 and 5 subtract 5 square root of 2. Okay? Yeah, Daisy?
Would you be okay if I solved it anyway with the calculator?
Sure, and it depends on the question. I mean, if it says to the nearest hundredth or whatever, then it's a calculator, right? If the book says do it to the nearest hundredth or whatever, then it's a calculator decimal question, right? If it says give it in radical form, okay? If the book or if I say give the answer in radical form, then I want that. If I say radical form, I want that. If it says to the nearest tenth, nearest hundredth, then just use a decimal. Does that make sense? Okay, let's look at page 110 in our journal, okay?